3 says Mrs. Walker flips the table in the air as she is known to do. The height h of the table in meters after time t in seconds is modeled by the function d of t equals, oh, that should be an h of t. Oops. Anyways, d of t equals negative 4.9 t squared plus 2.3 t plus 5. What's the maximum height of the table, and at what time will it achieve this height? Round your answers to the nearest hundred. Now, you could go through, use the equations for the vertex like we did in the previous problem, finding the x-coordinate of x equals negative b over 2a, plugging that in back to our function. Since you've already proven you know how to do that in the first two problems, you can use the graphing calculator. Now, since I can't show you a graphing calculator and apparently Air server crashes anytime I switch apps, I'm just going to show you the answers that I got after using a calculator. So I got an x value of 0.235, 0.3235, and y coordinate of 5.27. Now, those don't do us really any good until we pay attention to what we're actually talking about. Instead of x, we're actually talking about time t. Instead of y, we're actually talking about height or distance. Since I accidentally switched variables or switched letters there, which we call h. Now, so time t in seconds, we're asked to round to the nearest hundredth. So I'm going to say t equals 0.24, and we're given the unit of seconds. Please include the units of time. Our height, we're talking about meters, so we're going to do to the nearest hundredth, it was already to the hundredth, 5.27 meters. So make sure you're rounding properly and giving appropriate units.